The xLights source code, when you download it onto your machine, goes into a folder called xLights. You will need to download and install the Wx widgets framework, and it should sit in the same level as the xLights folder, because the xLights folder or the xLights code expects the Wx widgets folder to be here. This is the only thing other than the xLights repository that you need to download. It's just too large to include inside the xLights repository, so it's not included. Everything else that you need, including all of the other libraries that xLights depends upon, are included inside the xLights repository, other than the Wx widgets. If you are going to set up a build environment, you should choose the appropriate build environment document, whether it's OS X or Linux or Windows, and open this document up and read it very, very, very carefully. If you're doing Windows, which is the platform that I use, you will want to go down to, I use the Visual Studio instructions. The MinGW instructions we don't use anymore. I used the production release of xLights used to be built using the GCC compiler and the MinGW environment. We moved across to Visual Studio after we started encountering a number of issues mid to late last year. Mid to late last year, or maybe it was mid to late the year before. And so everything's now been moved across to Visual Studio. Visual Studio, like the GCC environment, there is a community edition of Visual Studio. xLights is built using that. You don't need to go and buy yourself a Visual Studio license, etc. But you do need to follow these instructions very carefully. There are a number of changes that you need to make to things in order to get things to work. You don't necessarily need to do the Windows installer piece if you're not building xLights for release, but this is used for building the actual release packages. But follow those instructions really, really carefully. You may want to install code blocks if you want to make changes to the xLights user interface. That's not actually done in Visual Studio, and while it's tempting to make UI changes in the code itself, I would suggest you don't do that, because any of your changes will be rejected. You need to make UI changes inside the code block development platform, because they have a tool in there called Wx and the Wx toolset maintains all of the UI code. And so if you directly manipulate the UI code and don't change it inside Wx, the next time someone touches that source file in Wx, all of your changes will be obliterated, and so that's not great. Wx is an absolutely diabolical piece of software. It's extremely it works, and it's just, it takes a while to get your head around, particularly when it comes to things like the sizes and everything. That's not a great example. Here's the Dmx panel, and so all of these red boxes, etc., are sizes that allow things to dynamically size, and you'll see sometimes in xLights that some of these things don't quite work right, and that's typically because even after using these tools for 5 years, I still can't make head or tails of it at times in certain scenarios. It just seems to have a mind of its own. But yeah, all UI changes are done in here rather than done in the source code or in Visual Studio. Let's get out of there. Let's go to Visual Studio. Actually, no, let's go back to the file system. So let's talk to a couple other things that are in here. Let's do a quick run through of some of the key folders here. The bin folders are where things are generally built to. Some of the things which are packaged in the final release also are maintained here. So all of the logging properties files, so these properties files here configure the logging in xLights. So this, well, that's the xschedule one, but there's an xLights one here somewhere, which, this one here, which is the file that gets distributed to the user when they install it. Here are the dictionaries for the phonemes which are packaged, etc. These are all the pre-built DLLs that are used in the release version of xLights and so forth. The build scripts folder, these days it just contains the Microsoft Windows one, so there are script files here for building xLights. This is how we actually build the release versions that go out. These ISS files are the setup configurations. The only one that changes regularly is this common file, which is where the version number's updated, and then I just double click on the command file and it goes off and it builds all of xLights, packages it up into the file that gets uploaded onto the website, which is the release version when that needs to happen. And the output folder is where the actual releases get built into before they get uploaded to the website. So that's the build scripts folder. The color curves folder, these are the pre-packaged color curves which are included in xLights. So look, if you wanted to come up with a new set of color palettes color curves or color palettes that you'd like to see included in xLights, these are, this is the color curves folder, here's the palettes folder, and here's the value curves folder that would then get included in the xLights build. In the root folder, there is actually a document for those people interested called dependencies.txt. This goes through and just lists out all of the other open source projects or other things that we have got dependencies on. You don't necessarily need to do anything with this, but if you've ever wanted to understand, the Z standard library that's used for zipping up the internals of the FSCQ file, which is the format that the FPP prefers, is supported by this library here. It happens to be a Facebook library that's open source. The WX LED library is used for some UI elements and so forth. So all of those things are all documented in that file there. Sorry, where was I? Controllers. Controllers is where the descriptions of the capabilities of all of your controllers are stored. So if you ever wanted to know how the visualizer or the upload of controller configuration validates that the way you've configured things in xLights is correct, it's all done using these files here. And so, if you were to go into the Falcon here, for instance, and the structure is not incredibly obvious, but there's effectively a hierarchy of settings. And so, the Falcon controller supports upload. It allows you to upload inputs only. It supports multiple simultaneous output protocols and multiple simultaneous input protocols, so everything doesn't have to be a single protocol. Universes, however, must be in numerical order because some of the Falcon versions sort the universes. It supports virtual strings, it supports auto layout, it requires or wants us to merge consecutive virtual strings. So if we were to remove this setting here, the Falcon would no longer merge all your virtual strings together when it did the upload. So things like that. It lists the pixel protocols that it supports and so forth. Right, so there's a whole bunch of these settings here, and there's a class inside xLights that deals with all of this sort of stuff. But yeah, if you're a controller vendor and you would like your controller better supported, you can play with the appropriate xcontroller file here, or submit a pull request and ask us to update some capabilities if we got things wrong. You cannot. Yeah, I got that. You can't find WX widgets as a sibling folder in the xLights folder. That's right, you need to download it. You have to actually go to the WX widgets GitHub repository and download it. We don't include it because of its size. The download folder is interesting. So if you wanted to add shaders to the shader download, there is this shaders.xml file which needs to be updated. So all of the shaders that you can download in xLights are listed in this XML document here. And Tony has been submitting pull requests to update that document to add additional shaders. So if you want to do that, you can. The rest of the files exist here, but they're not generally referenced here. They're referenced on the xlights.org website. but the master versions of them is maintained here, but we keep them elsewhere. The xLights faces is the index into all the downloadable faces. It lists the XML documents. Some of these are accessed directly by xLights, so when you try and do a shader download, it actually accesses this shader file. And this can be maintained by anyone. You can issue a pull request if you want to add a shader to the xLights download, and when it gets included, xLights everywhere immediately will start to pick that shader up from there. Some of the other files are not accessed here directly. They're maintained here, but they're copied to the xlights.org website and referred to there because for other reasons. So things like the faces, for instance, the face content is absolutely huge. It's hosted on the xlights.org website, but the index document is maintained here. The images folder is a bunch of images. The only thing to realize in xLights is images need to be converted into a format called XPM. GIMP is the editor that I use whenever I need to touch an image in this format. They're actually text files, which are then hash included into xLights. But you can actually edit them in GIMP if you want to, but then you've got to go and basically butcher them because GIMP changes some of the headers up here and that they need to be changed back. So they're a bit of a pain to work with. Images in general in xLights are a pain to work with because of the development tools. The lib folder is just a bunch of library files, which is where most of the third-party software is actually maintained. It's either statically or dynamically linked in, it depends. Then you've got the actual source code folders, and so each of the key elements of xLights has got its own folders. They do reference each other. xLights references some things in xschedule, and xschedule references some things in xLights. So for instance, all of the output processes in this folder here, which is all of the different types of outputs that xLights can produce to different protocols, all of those things are maintained in the xLights folder, but xschedule uses them. If I add a new protocol, like we did last year, we added the Kynet protocol to xLights. When I added the Kynet protocol, it got added in here, but xschedule immediately inherited the capability to output the Kynet protocol because it was because they reference each other. The other key folders here, if I can go through them, I'll just touch on the ones that have got interesting things in them. So the controllers folder contains all of the controller specific code. So if you want to see the HinksPix code, it's in the HinksPix folders. The Falcon stuff's here, the FPP stuff is here, SAN devices and so forth. All of that sort of stuff is contained in the controllers folder. The effects folder contains all of the effects. So every effect is maintained in here. So here, every effect has an effects file, but also a panel file for the UI for the effect. So all of those are in there. The models folder contains all of the various models in xLights. If you were a new person to xLights, I suggest you stay away from the models. They can be difficult to work with. Starting with effects is definitely a much better place to start your first couple of changes. The outputs, like I said, contains all of the protocol outputs that xLights can produce. The preferences panel is all maintained here. The sequencer maintains most of the effects grid type stuff, the elements, etc. And that's about it. Everything else just sits in the raw xLights folder, which is absolutely huge. There is a lot of code in here. A lot of code. The style in xLights is not consistent. It's developed over time. It's been influenced by different developers with different opinions about what things would look like. Generally speaking, we try to remain consistent to the developer that was in there in the past. Unless you're going to entirely bring it into line with some other elements, you generally just leave the style the way it is, and we just accept that that's how things are. Things are generally, so everything is written in C++. There's very little anything else in xLights. It's all, some parts of the code are really, really clean. The design's very consistent. So, things like the output processing, it was, I've reworked that a couple of times. It's all very consistent across all of the files. Everything, it's got strong use of inheritance where it makes sense. It's got very consistent structure in the files. It's all very, very clean. The effects are generally mostly pretty good. There's a couple of effects which could do with a bit more of a cleanup, but generally speaking, the structure of the effects is all very consistent. The models is a bit of a nightmare, and the way in which we manage the models is just horrific and desperately needs a bunch of rework. So, there are some things, and that's why the layout tab at times can be a little brittle, just because of the way in which things are processed. But let's dive in quickly to some of the effects. Let's do something that's maybe not too all over the place. I won't do the shader effect because there's a lot of extra crap in the shader effect. But let's do something really simple for starters. Let's do something like the on effect. So the on effect here, it's very simple. This is including the icon for the on effect. The way in which settings are maintained in xLights is using strings like these. So every control on the panel has a name. So if I go to this, so this is the UI for the on panel, which is quite simple. Most of this code is generated. It's in fact, the only code in this file here that's not generated is these few lines here. Everything else is generated by the Dmx Smith. The controller, the parameters settings have been given a name, and so these names here are the names of the settings, and these are then referred to in, they're slightly morphed, so they will typically have the ID will be chopped off and an E will be added to the front, but that will be the name of the parameter that the effect will then go and access. Over time, some things have changed, and so sometimes you'll see there's conversion code, etc. This sets the default parameters. So this is where when you reset the on effect to its default parameters, this is where that's set. Getting the effect string, the way in which settings for an effect are stored is they're stored in a list of parameter values. And if you've ever opened up a sequence and looked at how things are stored, they're stored as a string of parameters, and you can see here those settings and how they're saved inside those settings files. Value curves always have, so it's always E for effect, the type of the parameter. So this is a value curve parameter, this is a text control parameter. You'll see sliders occasionally, checkboxes and so forth. And then this is the name of the parameter that's being saved. So that's typically how things are stored. This here does the color background on the effect. Oh, sorry, this draws the color background, which generally is not done. And then this is the actual render. So this is the function that does the render. So you'd think the on effect would be quite simple. It's actually not. There's a reasonable amount to it, and that's because of all of the options. This here is grabbing all of the values for the settings. It's passed in as a map of settings, which is essentially an indexed list of settings, like a map, and it will grab all of those. Nothing here has a value curve. Is anything? There is a value curve. So here's a setting that is retrieved from a value curve. So the transparency is the only value curve parameter here, and that's how that's retrieved. So these things are all very standardized. You go to any effect and you look at a parameter that has a value curve, and it'll have something like this in it. The rest of the complexity here is largely down to dealing with all of the parameters and the various options that need to be displayed. So that is effect settings. Before I move on, key classes. So the audio manager does all the audio processing, including everything from loading the audio file, converting it to the fixed format that we use internally once it's loaded. It does all of the waveform parsing. It does all the fast Fourier transforms. Everything associated with audio is in the audio manager. Conversely, there's a video reader here that does all the video processing. So all of the video reading and conversion, etc., is all done in the video file. What else is kind of interesting? Render cache. So all of the render caching, all done by the render cache element. The pixel buffer class is pretty important. The pixel buffer class is the thing that deals with all of the render data. The way in which xLights works is when an effect is rendered, one of the parameters that is passed into the effect is, that's the panel, sorry, we'll go to the effect, is this pixel buffer, this render buffer. And this is generally black when it's passed in, unless canvas mode is turned on. If canvas mode is turned on, then the buffer will contain data. And effectively the effect is just writing into the pixels inside this render buffer. The pixel buffer class is then responsible for taking those buffers and blending them all together. So in all the transitions that you might experience, like fades, etc., the blur is all contained within this class. So yeah, all the blurring, all of those various blend modes that you might see are all contained within the pixel buffer class. Trying to think of which other ones are the core ones. The file formats are all maintained in things like the XML file. So this is the sequence file class. So everything associated with storing a sequence is maintained in the xLights XML file. The Rgb Effects File, however, is not there. That's actually much more distributed. There's a number of different classes that process the Rgb Effects File for each different section of the file. All your mapping when you do an import is dealt with by this mapping. It actually deals with multiple formats. It's not just the xLights import. Many of them use different ones. Before I hand over and sort of see if there are any questions, which there often aren't. There are also the other projects, so xSchedule is the other one that's significant. It has playlists. The playlist folder contains all of the various playlist items that are supported. So all of the different things that you can schedule in the playlist are in there. All of the events are in here, so all the things that xSchedule can react to are contained in the events folder. The other thing that's interesting is there are plugins. So the demo plugin, which is a C# shell plugin that you could customize if you wanted to create a plugin, is there. The Remote Falcon plugin is there. This is the SMS plugin. They're all contained in folders there. So I know that's been a whirlwind tour around the xLights source code. It takes a long time to get really intimately familiar with it, but to be honest, making the odd change here and there is not that hard once you can get a build environment up and running.
Has there been any look at integrating with the twinkly lights? I tried to go to the twinkly people and try to urge them to come into xLights, but I don't know if it's possible to go the other direction.
So Twinkly, to be honest, without a set of Twinkly lights, I have no idea what their protocols are, etc. We add protocols. We're an open source project. We try to be as agnostic as we can reasonably be. We've added support for a whole bunch of controller vendors over time. The project does somewhat support itself with some sponsorship, and so you've seen the Boscoyo and the Gilbert Engineering who both make generous donations to the project to include their models in the program, which we really appreciate their support. But in other circumstances, we add support because for the controllers, etc., and we've added those for all controller vendors without any ask for support, just because we tried to make things as simple to use for people as we can, and it made sense. Whereas the control of it, the Coro vendors always had the option of making their files available offline. It was more a matter of convenience having it in xLights.
Let's say we go into xLights and we try changing something and we break at it because we didn't really know what we were doing. What happens then?
So a couple of things. So first of all, you can't change xLights in a way that will impact on anyone else when you're tinkering with it. But when you've made your change and you're happy with it, you will do a pull request where you basically post your change to the xLights site. That change has to then get accepted by someone. Now, we would typically review your change at least superficially to see whether the change looks reasonable. Now, the more you work with xLights, the easier it is to get your changes included. People have a tendency to, we just accept changes from a whole bunch of people. There's a bunch of people who can directly commit to the repository, and then there are others that can't, but we generally accept their changes pretty straightforwardly. But if you're a new developer, someone's going to look at your code, do a quick flick through it. They may challenge you on some things. Please don't be offended, but you will get challenged on things to say, have you considered, and what about this, and I'm worried about that, etc. And we would expect you to go away and look at those things. The code base can be quite brittle. If you touch certain things, there can be consequences that aren't immediately obvious. And one of the more experienced developers is more likely to see that and flag it and say, hey, a little worried about this. And look, we've had examples of that in the past. The other thing is we kind of expect you to clean up your own mess. So if your change gets included and it blows stuff up, we're going to expect you to come back in and clean it up. Nothing more frustrating than having to spend hours and hours cleaning up a mess as a result of a change. But, at the end of the day, we're interested in having software that's reliable, and we will do that. We will clean it up and make sure that the bugs are fixed. We may reverse your change. That's fairly rare, but every now and then a change has been reversed. I've reversed some of my changes where, after a while you suddenly realize that, hey, that was actually not such a great idea. And in fact, the first changes that I ever made to xLights introduced bugs that I only found a year and a half later. But it's hard when you get into a new code base. You're going to make mistakes. Automated testing. If you want to write the automated testing, knock yourself out. Introducing automated testing into legacy code is hard work. There is some automated testing built into xLights, but it's more code that gets uncommented out and run because we know that the code's really complex and it's a chance that it will break. But, investing in automated testing in a code base the size of xLights is a huge amount of work, and it delivers no immediately obvious end user value, and so it tends to just not get as much attention as it otherwise might. There is automated builds, however. The Linux build builds automatically on every check-in. I get an email if it fails. It has a tendency to fail for reasons which have got nothing to do with the code being checked in, which is a bit frustrating. We have tried automating the Windows build. I spent a bunch of time on it. Scott's recently spent a bunch of time on it as well. It's not quite there yet. I ran into a whole bunch of, oh, there you go, Scott says it works. I ran into a bunch of issues with the old GCC builds, which were insurmountable, but the Visual Studio automated builds are a little bit easier to get going, and Scott says he's now got it largely working. So the builds help, but at the end of the day, most bugs aren't build bugs. Most bugs are logic bugs that cause issues in the code itself. Having the automated builds is useful though, because it means when someone changes it for one platform and breaks it for another platform, we get told about it pretty quickly. Although you'd be surprised how rarely that happens, given that, you know, I only test it on Windows, but I break it on OS X very rarely. It happens, but not often.